Following up with question 11, we were asked to use reference table G. Let's pull it up. So in this question, we are given 80 grams of substance. 80 grams of substance corresponds with the Y value. Here we can see that we have solubility in grams of a substance per 100 grams of water. So in this case, this 100 grams of water is just reassuring us that we're using this exact graph. And at 10 degrees Celsius. So this is x. So when we find this xy coordinate, 1080 will first place a mark on our graph. And we're asked which substance will have an unsaturated solution. If this was unsaturated, it should be under the line of interest. So potassium chloride is found here. Notice that the dot is under the line of interest. So this is an unsaturated solution for potassium iodide. Now, sodium nitrate, this line is exactly corresponding with the dot for sodium nitrate. So when the dot sits on the line, it is saturated. Potassium nitrate, this dot of interest is above the line of potassium nitrate. So since the dot of interest is above the line of potassium nitrate, that is supersaturated. And since the dot of interest is also above the line for sodium chloride, that is supersaturated. For question number 12, we're going to want to use the parts per million equation found on reference table T. Table T states that parts per million is equal to grams of solute over grams of solution times 1 million. So in this case, we are given 0.2 grams of solute and we have 1,000 grams of solution. We're going to multiply this times 1 million. When you place this in your calculator, you should get 200 parts per million. Please note that there is a mistake on this review sheet and no correct answer is provided. 200 parts per million is the best answer. Question 13 asks you to refer to reference table F and find which compound is least soluble in water. We worked with solubility not only when talking about solutions, but also when talking about reactions and reaction types. You should be very familiar with using reference table F. Let's pull it up. Recall that on reference table F, we have soluble compounds, and the exceptions would be insoluble. Then we have insoluble compounds, whose exceptions will make them soluble. And in this question, we are looking for the least soluble. On the regions, least soluble means not or insoluble. So which one is not soluble or which one is insoluble? In the first example, we have potassium carbonate. And we'll find that potassium is group 1. And group 1 is always soluble. There are no exceptions. So this is an aqueous substance. Next, we have calcium phosphate. Now here we can find the phosphates are insoluble except with group 1 in ammonia. And calcium is not in group 1. It is in group 2. So this is solid or insoluble. Now next, we have potassium acetate. Again, potassium is group 1. So anything containing potassium is soluble or aqueous. And lastly, we have calcium nitrate. Calcium is not listed as one of the major groups here, so that doesn't give us enough information, but nitrate is. And nitrates are always soluble with no exceptions. So here, the correct answer is calcium phosphate because it is insoluble. Now, we have already had an energy exam in chemistry, so we will not examine these concepts of energy on this upcoming exam, but we can review these, as review will be good for your mid-year exam. Question number 14 asks for the description of the transfer of energy between ice cubes and water. Remember that heat always goes from hot to not. So that means that thermal or heat energy is going to be transferred from the water to the ice because the water is hotter or warmer than the ice. Question number 15 asks us to look at reference table I. So let's pull up reference table I so we can see what's happening. So the question asks us to identify what happens with sodium hydroxide when it was added to water. So here is sodium hydroxide being added to water. Notice that it has a negative sign associated with the heat of reaction. The asterisk at the bottom or the key of the chart tells us that a negative sign indicates exothermic. So in this case, heat will leave the sodium hydroxide. So if heat leaves the sodium hydroxide, let's draw a picture. Here we have some sodium hydroxide, and the heat is leaving the sodium hydroxide because it's an exothermic reaction. If heat goes out of the sodium hydroxide, it will go into the water. So the water temperature should increase as chemical energy is converted to heat energy. Again, these questions on energy, which follow, will not be on your exam, though they should be reviewed at this point. How much heat energy must be absorbed to completely melt 35 grams of water at 0 degrees Celsius? Here, we're asked to calculate heat. Heat variable is Q. On reference table T, there are 3 different heat equations. Here, we're going to look for keywords. Our keywords are melt and 0 degrees Celsius. Whenever we only have one temperature, no temperature change, we're going to use Q equals mH. Now, the important value is to pick the correct heat term. In this case, since we're melting at 0 degrees Celsius, we're going to use the heat of fusion. Now, the heat of fusion can be found on reference table B as in boy. So here we have Q equals M, which is a mass of 35, times the heat of fusion, which from reference table B is 334 joules per gram. So the next question asks, what form of energy is converted to thermal heat energy when propane burns? Well, burning is a chemical reaction, so this would be chemical energy. Question 18 asks, when you take hot copper and put it in cold water, explain why the temperature of the water in the calorimeter increases. And that's because the heat from the hot copper is transferred to the cold water. To calculate the heat absorbed by the water, we know that the water's temperature changed. So we're going to calculate Q equals mc delta T. So since we have to deal with the water, we have 100 grams of water as our mass. The specific heat of water is found on reference table B as in boy, 4.18. And we know that the water changed from 23.2 to 26.3 degrees Celsius. This difference is 3.1. Question number 19 asks us to describe the kinetic molecular theory version of ideal gases. These are the 4 ideas that you just need to memorize. And ideal gases, or perfect gases, basically will move in constant random straight line motion. Question number 20 is fairly self-explanatory. So the kinetic molecular theory describes the behavior of gases so that the behavior of gases can be predicted using mathematics, in our case, the combined gas law. So question number 21 asks us about ammonia liquid, and they're held closely together by intermolecular forces. And basically they're asking, well, what's causing intermolecular forces? And intermolecular forces, now here we have ammonia. Ammonia is a covalent compound. How do we know it's covalent? There's no metals. It's all nonmetals. So there's no ions. So the intermolecular forces are different from bonds. So they don't have to do with electrons, which have to do with bonds. Instead, intermolecular forces have to do with uneven charge distribution, dipole-dipole force. Recall that when you have a polar molecule, you create a dipole, positive end and a negative end. And that positive end and negative end will be attracted to another molecule as opposite charges attract. So this is what holds a polar molecule together. Polar molecules, recall, are asymmetric. So question number 22 asks, based on intermolecular forces, which substance will have the highest boiling point? More intermolecular forces, higher boiling point. So when we look at these molecules, we have to find the one that has the most polarity, the most intermolecular force. Remember, polarity is the result of asymmetry. And asymmetry can be found by having a final subscript that ends in an odd number. Helium is a single atom, so it doesn't have any bonding, so it's has no polarity. Now, methane has a final subscript of 4, so methane is nonpolar. Oxygen has a final subscript of 2, so it is nonpolar. But water has a final subscript of 1. It's understood for oxygen, so it's polar. So water will have the highest boiling point. Question number 23 is a simple definition, but an important one for you to know. Question number 24 asks you to describe particle diagrams of bromine. The substance's identity is not important here. What's important is the particle diagram. And you should know that as you move from a solid to a liquid to a gas, the distance between the particles increases. Question number 25 is a calculation using the combined gas law. First, you want to look up the combined gas law in reference table T. So reading through the question, we'll see that the initial volume is 900 milliliters. And the initial pressure is 2.5 atmospheres. While the temperature is 298 Kelvin. We are looking for the new pressure, so that's X. When the temperature is changed to 336, and the volume is changed to 450, I highly recommend that you set up this system where you write down all the variables before you substitute and solve. Once I get the substitution, I would solve via cross multiplication. So now let's use the same procedure to set up question number 26. So in question number 26, we have an initial volume of 444 milliliters. And an initial temperature of 273 Kelvin. An initial pressure of 79 kilopascals. And we're looking for the final Kelvin temperature, so we'll call that X, when we have a volume of 1880 and a pressure of 38.7 kilopascals. So the first thing we want to do is substitute. The first step I would take mathematically to solve would use cross multiplication. Questions number 27 and 28 have to do with Avogadro's law. Question number 27 asks, 4 liters of oxygen have the same number of molecules as, so remember that gases have no real volume. So if they have the same volume, they'll have the same number of particles because their volumes are exactly 0. So 4 liters will have the same as 4 liters. The formula is not important. Question number 28 will not be heavily tested at this time, though it asks what phase changes are endothermic. Endothermic means that heat goes in. You must add heat to melt and evaporate. Question numbers 29 and 30 will also not be heavily tested. Now, question number 29, we're looking for the process of fusion, and fusion is freezing. And during freezing, it's a phase change. During phase changes, there is no change in temperature. Freezing is a colder phase change than boiling. So BC is the fusion or freezing. And then 30 asks, again it will not be tested, about line segment DC. Ask about the kinetic energy. And kinetic energy is the same thing as temperature. And here you'll notice that the temperature is increasing during line segment CD, while the potential energy remains constant. Only one form of energy changes at a time. Question 31 is a very important question, and it is a good review of the differences between solids, liquids, and gases. It may be tested. So at STP, fluorine is a gas while iodine is a liquid. And this is because fluorine has weaker intermolecular forces, so it doesn't stay together.